Prendo.
Yeah?
Allora, vi presento la dottoressa Fairuz Malek. Mi metto qua. Il curriculum vitae della dottoressa Malek è trovato sulla pagina web del nostro progetto. È troppo ricco, troppo lungo, non posso ovviamente raccontare tutto, solo molto brevemente che è direttore di ricerca al CNRS di Francia a Grenoble. Lavora da 30 anni nella fisica delle particelle elementari e parte della storia delle particelle elementari. È capo di un gruppo importante all'esperimento Atlas a CERN, dove sta studiando non solo la particella Higgs ma anche altri fenomeni delle particelle. È anche stato sempre molto attivo in tanti comitati, tante attività che cercano di portare la fisica nella società, di fare nuove connessioni, eccetera. La dottoressa Malek aveva un ruolo importante nella creazione di questo progetto, molto importante direi, e la dottoressa Malek è anche artista, perché ha studiato al Conservatorio di Algier il pianoforte, allora è una pianista di formazione, come Max Planck, anche Max Planck era un pianista di formazione, e così la dottoressa Malek ha nella sua vita, nella sua persona, senza di fare nient'altro, connette già fisica e arte. E nella sua presentazione di oggi la dottoressa anche connette i vari campi della fisica fra di loro. Oggi ci sono tanti che predicano il paradigma della superspecializzazione, dicono che i scienziati devono essere superspecializzati, altrimenti non possono fare ricerca. Ci sono i superspecialisti della supersimmetria, delle superstringhe, del supercollider e così via. Invece la dottoressa Malek nella sua presentazione ci fa vedere che si muove nella fisica delle particelle, ma anche nella fisica delle energie rinnovabili, sempre su un livello altissimo, rompendo questo paradigma. Allora ci fa vedere che la collaborazione fra i vari campi di fisica è possibile. Basato forse, questa è un'ipotesi, sul fatto che è anche artista. Si può chiedersi se cosa è possibile, la unificazione della fisica è anche necessaria per avere buoni risultati. Qua ognuno si deve fare la sua opinione. Io personalmente penso che la alta qualità dei risultati che presentiamo in questo progetto suggerisce sì, è necessario. E allora vi presento la dottoressa Fairuz Malek.
Hello, everybody. So I will switch to English because my Italian is just I know nothing, actually. Thanks, Hans, for the presentation. I did not understood everything, but I could guess what you were saying about. So my presentation. So I will sit down because it will be much efficient for me to deal with the computers. So my presentation here is in this context of ESOF with this topic of physics and art against fighting against the carbon dioxide. As you saw, this program is planned for a long since July 31st until September, and I am one among others that will be talking about this topic. But I will much focus on physics than art, although I am very fond of many of this part of this program and art too. Okay, so let's start with my first slide. The title of my presentation is the solution for a carbon dioxide-free planet. So, you are all living on Earth, like me, and you are experiencing a lot of things which are happening actually on Earth, and many of them are due to the problem that we are rejecting a lot of carbon dioxide in the atmosphere. which makes the planet getting crazy with the increase of the temperatures in some places. I forgot. With the elevation of the sea levels and many other of these this event that our planet is facing nowadays. So this is just a cartoon that I'm showing you here. This cartoon, in the left part of it, is a pot with frogs, and the frogs are an assemble of scientists and politicians. One frog is saying, "I'm slowly being cooked in a pot." And the other one is saying, "We're slowly being boiled in a pot." And the politicians are saying, "Okay, you see, the scientists have no consensus." So we are exactly in this situation today. The other thing is that what we are experiencing, you and me, every day now since the beginning of the year, it's a fight against a virus. We're wearing masks. And it seems that Corona has won the first round, and it's going to the second one, and the climate change is still waiting its turn to talk to us. So we are now in this situation, and luckily some people like us are trying to continue the fight and to try to see if we can make our planet better, including eliminating the coronavirus. So, as I said in the beginning, the human beings are rejecting more than, let's say, 40 billion of tons of greenhouse gases in the atmosphere. And this greenhouse gas is rich in carbon dioxide. It is rejected in the atmosphere, and it contributes to many things which we don't like. It's the increase of the temperature that we are facing and we are experiencing since more than 10 years or even more than that. The increase of the ocean level, the climate change, and many other things that are really bad, naughty, like the problem with the disappearing of part of our biodiversity. And we are also experiencing the beginning of sort of diminishing our comfort to face this problem. I found it very interesting to tell you that many solutions exist, and one of them is the decarbonization of our planet by techniques which are already tested and experienced in many places in the world, like Canada and US, China, by capturing the carbon dioxide before they are rejected, before the fumes. And they are either stored in earth and in dams, and they are then used, for example, to transform to object, or even used for heating, or building any other plastic object, for example, or energy. But these techniques are expensive. They are only afforded by countries like I cited, for example, China, US, Canada. These are solutions that may have a good, may succeed, but we need more people need more work and more tests and probably more money to do such a thing. So in the meantime, we cannot wait until this is implemented, and we cannot just wait with the comfort we have. So we need other solution. So the other solution are known to everyone already. The solution to lower the so-called toxic carbon dioxide, because you know that photosynthesis is using carbon dioxide. So carbon dioxide is not bad in general, but if it exceeds an amount, so it becomes very toxic, like increasing temperature, whatever. So this solution that you know already is are using natural energies like sun, wind, hydroelectricity, geothermal, and I have added nuclear power plant because I think this solution, although it has some safety risk, is nowadays efficient. So in this table you have the pro, the things that are efficient, the pro, what is good using this technology, and what is bad using them. And for example, if you take the example of the photovoltaic, well, we're using the energy from the sun. That is true, but we are also using silicon technology for the photovoltaic plates, which is produced and is polluting. So this is against this technology, although we don't have better to provide, and economically is a little bit weak. And you have here in this table, if you want, I can tell you one by one, but actually most of these technology are mature, and as of today, they cannot be, there are no progress as of today. Of course, maybe any other progress may come in the coming years because people are working hard on that. But anyway, so these technology are also providing electricity and energy, but they are not providing, apart the geothermal one, they're not providing renewable heat. So our project will be within the idea of producing renewable heat. We don't have other solution to put in face of photovoltaic or wind turbine or whatever to produce electricity or energy, but we have other solution to produce heat. Okay, so now I will tell you something about my background, and actually it's not only my background, but Marina Cobal background, Hans background, Sandro background, many others, because we are doing basic research, and basic research is actually what is pushing us to look for progress for humanity. So what I am doing actually is fundamental physics research on accelerator. So you know that physics is a Greek word which means nature. Okay, so physics is matter, it is nature, it is cosmos, and physics is knowledge that we are seeking as human being. And the part of knowledge that I personally is seeking on doing particle physics, for example, on accelerator, is the one which is in this scheme. In this second part here, this one, where 10 minus 10 seconds after the Big Bang, quarks and gluons are there, and after thanks to the strong force, they produce proton neutrons. Proton neutrons will produce nucleons, atoms, molecules, and 15 billion years later, we are here, human beings on Earth. Yes. So this is all the knowledge that basic research and physics is seeking. Okay? And part of this knowledge that we are seeking on this accelerator on particle physics is what I have illustrated in the left part, which is called the Mexican hat. And the Mexican hat is just a jargon because in theory we represent the mechanism of Higgs as a Mexican hat, and this is the Higgs boson. So this is what we were seeking for years, and we discovered it. But still, we discovered something. We did not discover everything. We have still to do. For example, we believe very strongly that in the beginning of the universe there was one force, and we would like to do our research in view to unify all this theory and to prove that in the beginning of the universe there has been only one force, which is called the grand unified theory. Okay, so doing this research, which are basic research again, maybe they will come with something for application, maybe not. We use particle physics accelerators. So this is just for the fun. I show you here a picture of a piece of the accelerator that in 1930 Ernest Lawrence has built. It has cost only $25 to build this cyclotron. And in 2020, we have a Large Hadron Collider, which cost billions of euros. With this Large Hadron Collider, which is 26 kilometers of circumference, which is located in between France and Switzerland, we have a huge experimental setup, a huge experiment like Atlas experiment where Marina and myself belong. And on this experiment, we do our basic research. But doing basic research to search for a Higgs boson, a grand unified theory, or whatever things that is for you maybe something very weird, goes through very wonderful things, because these are pieces of art, these are detectors. We are building detectors at the limit of technology, because we are willing to do research as precisely as possible. So we are prototyping, simulating, testing, construction. It takes years, it takes decades sometimes to reach the detector, and it takes even more than 10 years or 20 years to discover or not basic research, the research that we are doing and the research that we are presenting. So this picture is just there to show you that basic research is also innovation in technology and instrumentation. It's not only innovation and technology and instrumentation, but also in computing, in software. So to be able to do our basic research, we had to build a great technology, computing technology, where computing centers are are distributed all around the world, and all the data are distributed all around the world for everyone to use them. So we are sharing the information, and we have built new technology for computing. So to look for a Higgs which is decaying to 4 electrons may take a long time. It takes sometimes 2 years before we get this picture of a Higgs decaying to a 4 electrons. And for this, we need to perform in the software, and we are using since decades, since 20 years, since more than 30 years, we are using very typical software that we are creating that is very famous nowadays, that we call machine learning. So we go from raw data, we calibrate, we reconstruct the pattern, we analyze the data, we compare to theory using a neuronal network, whatever, things like that. So this is, again, innovation, not in instrumentation, but in software, in computing, in machine learning, or whatever. So what I wanted to demonstrate here is the fact that doing physics and basic research may have many spin-offs. Not immediate application, but spin-off. So the famous www that you're using every day comes from the fact that we needed an interaction between physicists. So it was created at CERN because of our need. So in the left part of the slide, you see that the World Wide Web in the 19s, how it looks like, and nowadays how the World Wide Web looks for you as a citizen. You can use it. At that time it was more complicated and more complex for us, but anyway, it comes from physics. But more, also maybe that from accelerator physics, we have a very nice spin-off, which is proton therapy, synchron cyclotron, and many detectors that we're using in medical physics. But that one thing that you may not know is that the touch screen that you're using every day on your phone was designed at CERN in the 70s. Yeah? So this is just to let you know that although we have a background which is in other field of physics, this field of physics is very rich in providing spin-off, experience, or whatever that we may use in other disciplines. So this is why now I'll go to the heart of the talk. So what our experience in physics and basic fundamental research would provide to as a renewable heat for freeing the planet from carbon dioxide. So this is already said in the beginning. We are facing a lot of problems with climate change, and maybe one of the solution that we may provide, which will be a clean solution, would be heat production. Sorry. And for this, we're using solar energy, and one of the promising technique would be to use a linear mirror. So looking at this map, which show you the radiation, so it means that here, if you look at that map, you think that if you want to produce energy or use solar energy, you may want to go to Africa only. This is what the map is saying here. So from this map, one may think that going to Africa using the known technique of curved mirror, or a photovoltaic curved mirror, one can produce energy there and transport it, for example, to Europe, because we are not able to produce energy in Europe, especially in the northern part of Europe. So this is, for example, sorry, I'm looking at my at my laptop. So this is an example of a solar plant which is located in Morocco. It is called Noor. Noor in Arabic means light. So this is a technique that is nowadays used in Morocco, and if I'm not mistaken, it is also used in Egypt partly, and in Spain. And of course, this is one solution for local people who probably have had no light. So that was really a progress for them, because in Morocco, a poor country, an arid country, dry country, they have no light. So this is a big solar plant built in Morocco. But one may discuss this regarding the fact that it is built in Morocco. It was in the beginning planned to transport energy to Europe, but at the end it didn't work because it is costing a lot. And the second thing is that this technique is using also water. Water is taken from underneath, and you remember this is in Ouarzazate, it's south of Morocco. So you are in dry country, okay, you're using solar energy, so you're heating more the country while the temperatures is increasing because of climate change, and you are wasting water, local water. This is, for me and for many people, is really a disaster. And it's not sustainable. You have to maintain it. You have to put a lot of money. And you have to have a lot of funds. So how much will it last? We will see. We will see in the future. In 10 years from now, we'll see how it will go. So if you look at this map, which is showing the irradiance, as Hans explained to me, it is the direction of the sun, and here what is taken into account also is the cloud. So if you compare this one to that one, the difference is that if you go and look at the temperature in Finland and you compare it to temperature, but not the temperature, the kilowatt hour, the sun that you collect in Finland, and you compare it to what you collect in sub-Saharan, it's a factor of 5 if you look at this map. Now, if you look at this map, it tells you that it is only a factor of 2. If you look at this map, it means that you may have a solution also to use solar energy in more northern country, but using different technique, of course. This is why, driven by our friend Hans, and under his responsibility, and also that he built this project long ago, which is called Isomorph, using the linear mirror. There is a project that is already can be shown, that it uses linear mirror, which are and the heat exchanger. We collect the hot air. Then we add to this a toaster which roasts biomass or waste mass. Biomass doesn't mean that we are roasting trees, of course. You can use any waste. And you produce the heat that you will provide to a client, okay? So this project has been already shown by Hans in the beginning of this event. So actually the cycle is this one. So you use natural sun, of course, linear mirror, a heat exchanger, a gasifier, and at the end you provide the heat to a house or to a city. This is why, not why. So we were working on this with Hans and with a small team, international team, until we saw that there is a Helsinki Energy Challenge, where in the Helsinki Energy Challenge, the client is the mayor of the city of Helsinki, and the goal is to provide the heat, not energy, the heat to the city of Helsinki. So in this challenge, by 2035, Helsinki would like to have as clean as possible heat to provide to the city without using too much biomass. It means we should not destroy forests and trees. So we think that is an opportunity for our team. So we jumped onto this project, which is ongoing. The next step will be to provide the final application by the end of September, and the winner or the winners will have to share billions of euros, and they will know about it in 2021. And as an example of what we in this challenge will provide is what I have shown you already is this system of linear mirror providing heat to a house or to a city. So if some of you are interested to see this, this is not a prototype, but this is something which was installed already 6 years ago. Yes, 6 years ago, and it is possible to visit also. So it is in this region. In case you want to visit, you ask Hans to show you the way to go. Okay, so let's go to my conclusion and prospects. So we have together with Hans Grossman, Marina Kobal, and myself, and a team of people all around the world, in US and in Africa, decided to join our effort. Many of us are more in basic research in particle physics, like Marina, Hans, and myself, and Ketevi actually, and some others are more solar energy oriented, like our friends Daniel XB, who is in Linz in Germany, and our friends in Senegal. So from the beginning, we joined the effort on isomorph. Then we jumped to more ambitious projects. So we are going to try our chance for Helsinki project. And in parallel, we are working on a project of a steam turbine based on on the process of an eolipi. This will be shown by Juma Kobor in August 26th. And we have already a network which is between Europe and Africa, which is solar energy network, which is coordinated by Daniel Egbe. And we would like to participate also with Daniel Egbe, who is actually in Africa, for in-place entrepreneurship for providing heat using solar mirror. And last but not least, Hans have applied also to Solar Impulse Foundation. This is a foundation which is trying to boost solution for the protection of the environment, and it has the aim to provide 1,000 solutions worldwide. But okay, we applied. We don't think we are going to win anything because if we understood the problem of nowadays, even foundation has a very nice goal. It would like to make some profit, money profits, so they prefer a project which are applied immediately, make money immediately, and don't waste too much in research. So, and this is not exactly what we would like to do. But Helsinki project, for example, giving us more time to make research and progress and demonstrate a solution that is probably the good solution for them. And I have a last slide about my conclusion. So the need to fight against carbon dioxide for us is the need. It needs open-mindedness from the researcher first, because they should not be in their comfort of research and say, I'm particle physicist, I'll do only particle physics, but I have some experience, I have skills, I know many things, I may find time and money, and even I may find ideas to help. So we should overcome intellectual and cultural boundaries. And this is exactly in the spirit of ESOF event, which is actually science in the city. So for us here, it was really a nice opportunity to build an international team, which is very young. Actually, it has less than 6 months or 6 months, something like that. And since 6 months, we have done a lot. And we are really happy, and we are going to would like to serve society, and it involves academic, which we are academics. It involves people who would like also to join, which are in the industrial, and we are going to also to face challenges like Helsinki challenge with stakeholders and policy makers. That's it. Thanks a lot.
I would like to thank Dr. Malik for this wonderful presentation. And I'm sorry, I did not realize that I presented her in Italian. Maybe I should have spoken in English so she could not understand what I was saying. So if I said something wrong, you should tell Dr. Malik, but I hope not. And if you would like to make questions, of course, you can ask in Italian, and then we can translate.
Yes, Hans would answer about the technical things. And in Italian.
Maybe Dr. Scandalo would like to say a few words to us.
So my question is, as you correctly alluded to at the end, one of the important aspects in promoting the technology is also the incentives of the government, political level, is speaking to the technology. So I'm curious to know how you manage to involve policymakers in your projects, because that, at least as far as I can see, is the most difficult part for a scientist. how to convince policymakers that the technology is interesting, useful, and therefore requires support.
Yeah, actually, this sentence I put is probably a little bit ambitious. So we would like to serve society. This is clear. We are academics. This is clear. There are some industrial that will come with us. This is clear. Stakeholders are Helsinki project, for example, or any other projects that we are going to apply to. And policy makers are those who belong to this project. So these are people who are putting policymakers. But then we have also the intention to go to talk our institution, to our funding agency, our university, to make them possible people who can join the effort. Yes, Marina.
What Dr. Scandal said, it's really true because it's the main point. Because at the end are the policymakers which can change, but policymakers can be pushed by us, by the society, and also by the institutions. So, for example, our aim is also to try to involve main institutions like ICTP, and we are very glad that you are here, but also INFN. In the last conference, the director of INFN was here. And for example, INFN had a very strong reaction to the COVID emergency, which came since, well, in Italy since January, February, but climate change is an emergency since I was a child. We were a child. So it means many, many years ago. And also INFN, for example, could do something. They have some activities, but this can be even strengthened. So we're also taking contacts and building relationship to make this involvement much stronger. Because as Feruz was saying at the beginning, the pandemic is an emergency now, but there have been other pandemic emergencies which at a certain point, let's say, are dumped. Let's hope this as well. The climate change is something which is in between us since decades, and we are still dealing with the problem. So we have to act more on education and also on involving more institutions which can make pressure on politics.
I agree that it's very difficult to get stakeholders and policymakers involved, but I think the even bigger problem is to give them knowledge about the situation. Because, for instance, the Italian government made a very nice law which is Decreto Clima, and when you read it, you see that they have no idea what they're talking about. It is not about climate. And so they need us. So I think we need to be the ones who really develop initiatives and produce results and show up. And then this is a precondition for it. It's of course true. It's a very difficult task which comes next. But first we need to do our job. And I think that physicists in general can improve on this. They can do very much more than what they have been doing. And then, as Fairuk said correctly, you have opportunities like the Helsinki Energy Challenge, where people are forced to look at what you present and to evaluate it. And so I think there are chances where we really can make an impact. But first we have to do our homework.
Yeah, I think you're right. We need to jump to projects like Helsinki or Solar Foundation, whatever things like that, because we can't just make research, basic research, and we're happy of what we are doing. But if we are not faced to challenges, then we can't do all these things that I'm talking about. I mean, yeah. So we have to face the real thing, and then okay, oh wait, I need to look at that. I need to innovate in that, and so on. Yeah, and even with policymakers, it's the same. I mean, the Helsinki project, for example, is a Helsinki mayor project. So it's a the city project. So policymakers are there. They will be watching out what's happening.
In this respect, working with cities, municipalities is probably
yeah, exactly. This is a real challenge. Really, really big challenge.
Potete chiedere anche domande in italiano, possiamo tradurre se
Which are the most proactive countries in Europe or in the world looking for this solution? This kind of
the heat or the renewable energies in general?
no, the reduced, the neutral position considering the CO2 as the LCP.
I would say everywhere. I would say I am positive, except in countries where the emergency is, I mean, Western country, of course, there where research exists, because when you go, if any bad, I mean, if you go, for example, in Indonesia, where they are facing the increase of the sea, for example, so they are more focused on this research, or what to do, how to deal, to immigrate or not, or to build walls or things like that. So it depends on this situation.
Yeah, but they are still developing all the refining oil and gas market.
Yeah, of course, because the emergency creates needs which should be applied immediately. So this is why, yeah, the known solution are okay, but we need to go over the known solution. And then my feeling, and I think Hans may confirm that my feeling as of today, all these companies which are pushing for renewable energy project, whatever, like Solar Foundation, are just would like to make a communication impact. So it's just, yeah, Solar Foundation, yeah, it's a solution. Well, yeah, but which technology are you using? The known technology, of course, because it has to be applied, has to produce money, whatever things. The only thing that we saw with the Helsinki project is, I'm talking about that one because that was really something very challenging, is that they have really clear requirement. We need clean energy. We don't want biomass. We don't want to burn our forest and things like that. So you are forced to make innovation, for example. Yeah. And we need heat instead of just energy or electricity. You see that. So in the city, so you have also to face the fact that it is in the city. So the technology should be also adapted to the city, not just to put in the desert. Yeah.
Maybe I can just add something.
Yeah, sure.
Fairuz doesn't know this, but in Italy there are very strong examples for what she said, that there's a lot of publicity of, instead of doing something real, when you watch the television in Italy, you find often publicity from Enel and companies like this, which make a very nice movie, and you have somehow the feeling that they're working on renewable energy, that they're saying something about renewable energy, but there's really no content whatsoever. You have to help, or you must be involved with sentences like this, which just give people a feeling that somebody thinks about it, that cares about it, but without any content whatsoever, only publicity.
So if you take the example of Noor, which is in Morocco, in Ouarzazate, they built Noor 10 years ago. This comes from Desertec company. I told you the story about Germany willing to take energy and driving it to Germany, whatever. So this is Desertec from the beginning, and now it is Noor, and they're building Noor 2, Noor 3, Noor 4. But all the technology is based on photovoltaic, low-cost Chinese photovoltaics. So they just buy, yeah, they just buy it and install it. That's it. And then there is no research behind it. So to either to maintain it or to improve it. Maybe they can improve. I don't know. Yeah.
Well, just one point that being proactive doesn't mean being right. Because, for example, I was very much surprised by the case of Germany, and that's probably can comment better than me. Germany apparently made a lot of investment in renewable energy. In Italy, it was like an example, a lighthouse in Germany. But then, very recently, there was a sort of summary of what happened with the renewable energy commitment in Germany under the Merkel government, and it was not a very positive
No,
conclusions, no?
Germany is a total disaster. They were making publicity, as Raoul said correctly, spending something like 30 billion each year for photovoltaics, for instance. And everybody knows it will help CO2 increases. And what they're doing right now is spending a lot of money, sending it to Africa, where it's not used to promote African physics, African science, and to make technology. No, says chunk technology, which is used as in Europe to Africa, but is equally useless, but they have spent the money and they think this is their job. And this is, I think, very, very wrong. And here again, physicists need to stand up and explain these things to people, because in the newspapers nobody explains these things. So we are really needed in order to explain. I think that many people, many politicians even act in good faith. They are honest, they want to do something, but they do not know. They have some expert who tells them what he is paid for to tell because he's a lobbyist maybe. And so physicists can and must do very much more.
I mean, photovoltaic is accepted for certain things in
Yes,
certain places.
of course, yeah. Photovoltaics is wonderful
But
up
not
to
for
some
everything,
point.
and it's not the final solution.
I think what happened with Germany is, I mean, really the bad example, because in Germany, they, of course, they would like to participate as the other countries in Europe and elsewhere to lower their pollution, like carbon dioxide or whatever. So if not, they have to pay taxes or yeah, exactly. So this is the Protocol de Paris, for example. Yeah. So they go aroundish. They go aroundish this, and they put money on project like Desertec or Noor or whatever things, and saying, "Oh, you see, we are putting our money for this type of energy, renewable energy," but they're not making really any improvement on in the technology. They are just putting money, saying, "Okay, this," and then it lowers their rate of carbon dioxide pollution in Europe. That's it. Many countries are doing this, actually, not only Germany. Sorry?
Not beautiful.
No, not beautiful. Yeah. So, I mean, the renewable energy. I come from France, so, and I come from a region in the Alps where it's a city 100% clean. We use hydro electricity because of the dams and Alps and lakes and water, right? And we use nuclear power plant because France is 70% of nuclear or electricity is power plant. So my favorite, my favorite, my favorite energy as of today is hydro and nuclear power plant, because I see that it works. The city is really a clean city. I mean, it uses clean energy, clean electricity. But we should move from that too. I mean, some years from now, okay, hydroelectricity. And I don't know if the ice will still be there in 10 years from now. So water and ice and
Nuclear waste will be
nuclear waste. Yes, nuclear waste.
Add something, this is also for very interesting. In Helsinki, there is another suggestion apart from ours, which is a Chinese company who wants to build a nuclear power station at the city of Helsinki for heating. They have already nuclear power stations 70 kilometers away from Helsinki for electricity, but you cannot carry hot water over 70 kilometers. So the Chinese really suggest to make a nuclear power plant at Helsinki in order to heat it. And of course, if this is adopted, if they really do it, it will be a total disaster, because Helsinki is justly considered a role model for all of European cities. The European Union has given a prize to Helsinki. They say it's the most advanced city in the field of renewable energies. So if they would adopt a nuclear power plant, a few years later we would have the same kind of power plant in many European cities. And there would be no way to go back, because how can you go back if you have these things constructed, say it's the here 20, 30 years?
How about the hydrogen?
Yeah, sorry. Hydrogen.
I know this is also a very important part of
Yes,
our
I did not
approach.
talk about it. Hydrogen, yeah. Hydrogen, so it's like electric cars use batteries.
No, because
So you store hydrogen in batteries, no?
I saw.
No, I don't know. I know nothing about it actually. Let's say stupid things. Do you
Yeah,
anyone?
this is a subject of another presentation we will have
There is one.
on 8 of September.
Oh, okay. Good.
Because you see, when you just add as a gasifier, so what we can, as Svalbard explained, do is roast cheap waste biomass, dead biomass, which we decay anyhow. We can roast it with hot air from the sun, so it becomes solar carbon. With this gasifier, we can gasify it, and the gas contains hydrogen. Biomass consists almost of 50% of hydrogen atoms. So biomass is a most excellent hydrogen storage. People do not know this, but it's true. It's true. And so based on that, you can then make a hydrogen economy which is really sustainable. Because if you produce hydrogen, let's say with electricity which comes from a nuclear power plant, that is not so good.
Yeah, so it should be sustainable.
So it depends on how you make hydrogen, and with this solar carbon we have a way to really make hydrogen without making CO2, without nuclear waste, just in a sustainable way. And so also this is something we need to create more collaborations, maybe with the ICTP. There's so much to do. And maybe Faris was too diplomatic to say it, look around at ESOF, which is the European Science Open Forum. Scientists from all of Europe come to present their work. You would expect that there are a few who present new technologies for stopping CO2. There's nothing, zero, nada, not even one. Only this event where we work together with artists. And I think that's very meaningful. It means we really need to have this new way of doing science together with culture, together with artists, physicists who are like Farouz also artists. I think that really is important.
There was a question there? No, it's okay.
No questions anymore? So I would like to thank very much Farouz Malek. I also would like to thank
Yes,
Skandal
thank you, Sandro. ICTP is here. It's
and
good. And all the people that came here.